Okay, good day to all of you. So in this video tutorial, you're going to learn how to make an LED blink. So using Tinkercad, specifically inside Tinkercad, we're going to use a virtual Arduino Uno board and a breadboard. So for this tutorial, we've already started. We're already inside the Tinkercad workspace. So unlike the Arduino board, the actual Arduino board, and the Arduino IDE, which comes first, electronic component setup or coding the Arduino sketch. So with regards to the first condition, the actual Arduino IDE and the Uno board, it's up to you as long as the pins that you have written for the code and you have set up in the electronic components are just the same. But in Tinkercad, it's a different story because if you're going to click its code editor, you will have a message here that no programmable components in this circuit. So it means that before you code, you must make sure that you've already set up the electronic components needed for your mini project or of course complex project. So before we start, so let's rename our projects since this is an auto-generated name for your projects, Miguelo. So let's rename it describing what this project will do or what's the function. So let's put example blinking LED. So it means that your project is for blinking an LED. So now that we have already renamed and named our project based on its functionality, so let's drag the Arduino board in the workspace. Okay, let's wait for it to be loaded and appear in the workspace depending on your internet connection. So we already have the microcontroller, and then we also of course need the breadboard. So again, let's wait for it to load. So we already have an Arduino Uno and the breadboard. Okay, you can maximize your view by means of your mouse scroll wheel. So, and make it bigger or smaller. Okay, since we're going to make component setup with the Arduino Uno and the breadboard. So let's arrange again. It depends upon your preferences if you want to do it like this, but if you want it in a more organized way, you can do so. The only important thing here is actually the connections. So I would like my Arduino Uno to be uh, in vertical position. So again, let's select the Arduino Uno. Okay, so we already have this one. And then you just put in okay, um, in the workspace where it can be seen. And then also our breadboard. So click our breadboard and rotate it. Okay. Okay, so that will be our initial components, the board and the Arduino Uno microcontroller board. Okay, since our function or the purpose of this project is to make an LED blink, so of course we need the star of this project, the LED. So let's drag it into, of course, the breadboard. And then this is the orientation for horizontal. So since I rotated the breadboard and the Arduino board, I have to rotate it too. Okay. Sorry. Oh, I have to repeat it again. Okay. Okay. So, and then you have to make sure that it is connected on the points. Okay, there is a label for the anode and the cathode. At least it is said that the anode is the longer leg and it should be connected to the power source or to the pin where the LED will be assigned. And of course, we have the cathode, which is connected to the ground. So we already have an LED. And then of course, we need a resistor. So let's also drag the resistor into the breadboard. So you can make one, it does not matter. So let's just make it, for example, 100. And then, okay, you want to adjust the space so that it will be, since this is only the LED, you can take up the space for the breadboard. And then rotate it also because this is oriented for the horizontal breadboard. Okay. So, let's connect it in here. So, it is said again that we need a resistor because the LED draws power to itself, more power. So, it will result to premature burnout. So, we already have a resistor. And then, next is we have, let's connect the wires. So, wires, unlike the actual setting up in the Arduino board, Tinkercad, you just need to connect the points. So we have this one. This is the ground. So it is connected to the ground. Since we have the ground here and also the ground here and another ground, you can choose whatever because they're just the same. Their functionality are just the same, of course. So since this is nearer, so let's connect ground, a wire going to the ground. Okay, then click so that it will snap. And then, of course, if you don't want to confuse yourself to the color of the wires, since ground, its standard color is black, so we can put it black. And then, so from here, okay, or since this is the ground, you can put it, oh, can put it in the end so that this remaining points will be used by your components if ever you have very many components that need the ground signal. Okay, so next is we have to connect the ground. So just choose any of this of the points here since this is again all for ground signal. So let's connect. Okay, and then let's name it, for example, again, let's make it black. So again, for the ground. And then for your um, anode, so let's assume that our pin number will be pin number 11. So again, so make okay, to avoid errors, make sure that your wires and your components are aligned so that you will not have any errors or misconfigurations. So since we've assigned example our pin to pin 11, so from here any points from here are the signal for the anode of the LED. So we have 1, 2, 3 more points. And okay, anywhere from these 3 points. So for example, I want the wire to be go to start from here and then go to pin number 11. And then let's make it a red, for example. Okay. You can assign actually colors for the wires, but then for standardization, such as for ground, the standard is black so that you'll not be confused. Oh, black wires is for the ground. So, we've already set up for our LED. So, next is, let's see if the code editor is already enabled. Okay, it is already enabled and the default is blacks. Okay, so you can also learn the black black way of programming. But since we're using the Arduino and the Arduino IDE has the standard text editor style like the other IDE, so let's just convert it, or let's just go with the text editor for the code editor. So again, the Tinkercad is asking that, are you sure you want to close the blocks editor? Any blocks you currently have will be lost. The code in the text editor will remain and become editable. So continue. Okay, since as I've already said, since I already used it for a sample Arduino sketch, so let's just remove the contents. Okay. Okay, so it's a good programming practice that instead of using the pin number, let's define it to make it more descriptive. So we have LED underscore 1, and then as you can remember that you have assigned the LED pin to pin number 11, so make it 11. And then we have the void setup. Since we have an LED which is assigned to 11, and then we need to declare this LED, which should be the declaration could be an input or an output for this example. Since LED, again, you have to understand the nature of your electronic components since it is an output electronic component. So for pin mode, so again in camel case, pin mode, and then the name of the variable LED underscore 1. And then since again this is an output electronic component, so you have to type output. So again, pin mode is for initializing your electronic components, or it's like introducing your electronic components in the Arduino sketch. So again, pin mode, the name of the variable, which is for our example is LED underscore 1, all caps, and then is it an input or output? Since it is an output electronic component, so we must declare it properly and into output and not for input, because LED is never to be an input. Okay, so we've already declared our output electronic components in pin mode, and then next is we want to make the LED blink continuously, so we have to put it in the loop function. So for the loop function, we have, okay, digital write in camel case. Okay, digital write, and then LED underscore 1, and then high. So what does this line of code suggest? This line of code suggests that digital write, you're going to change the state of your input or output device. For this example, we have the parameter of digital write is the variable, and then for digital write, there are only two states. We have the high and low. So this line means you're going to, in layman's term or a non-technical way of explaining this line of code, is that you will uh, turn on the LED. Okay. Then the next line is we will have the delay function. Okay. And then put 500. So delay function acts like as a limit for your input or output depending upon the situation. So we have this delay after the digital write, and then we have 500 as its parameter, which is a value. So what does this mean? So delay 500 is its time is in milliseconds. So it means 500 is half a second if you're going to um, use it. If you want to show, for example, instead of milliseconds, there's, example, a specified in the problem that the problem wants it to be 5 seconds. So, to emulate or to show 5 seconds for the delay, add another 0 because 1000 millisecond is equal to 1 second. So if you want to use 5 seconds in the delay function, so you must convert it that 1 second is equal to 1000 seconds. So it means 5000 milliseconds is equal to 5 seconds. So this 5000 here in the delay function is actually 5 seconds. So let's return our for our 500 for half a second. So, what does these two lines of code mean? It means that the digital write will turn on the LED for half a second. So, that's the meaning of these two lines of code. Okay, so since our project is blinking LED, so it means you have to the LED must be turned on and off repeatedly and indefinitely as the Arduino has power. So this lines of code is for turning on since we're dealing with blinking. So we should have a mechanism of how to turn it off. Actually, the way to turn it off is just the same line of code. We're just going to change a particular parameter. So again, to turn this two lines of code again is for turning off, for turning on rather. So for turning it off is we have digital right LED underscore 1 and then we have low. So this line of code means you're going to turn off the LED. And then, since blinking, so we have a delay for 500 milliseconds. So for low, let's also put a delay which is the same. We have 500 milliseconds. So this line, 4 lines of code means, and in half a second, the LED will turn on, and then after half a second, the LED will be turned off. And then, of course, since this is loop function, anything that you put inside the loop function will be run repeatedly. So this will run on, off, on, off, as long as the Arduino has its power. Okay, so let's check if we correct if we did our code correctly. So let's start simulation. Actually, there is no verifying or no uploading in the in Tinkercad. So let's start simulation because by starting simulation, the compiler will check if there is an error or it will reflect in your model or in your prototype that is it working or not. So let's click start simulation. So we have, so you can see this is already uh, working. So you can see that the LED is turning on and off for half a second. So, okay, it looks like the LED is not very bright. So, it's because of the resistor that we are using. So, let's click the resistor. And then, okay, let's wait for the dialog box to appear for the resistor. Okay, resistor. Okay, let's make it 1 because the our kilo. Okay, let's make it 100 ohms. Let's see if there's a difference in the brightness of our LED. And then again, let's start our simulation. So you see, I used 100 kilo ohm, and then when I used 100 ohm resistor, so it is brighter. Okay. So you can see for half a second. Okay, so let's play with our okay, there is a little discrepancy, maybe because of we are using online. Again, it depends upon your internet connection. Okay, so it blinks for half a second. So the simulation, okay, so why not make it, okay, faster. Okay, let's make it 100 for the delay. And let's see how fast our LED will blink. Okay, again, depends our with our internet connection. So you can see it is blinking faster. Okay. So you want to, okay, it does not necessarily mean that the delay are the same. You can again play with your delay. So for example, make it on for, okay, since again, we're still in simulation, we cannot edit it. So we have to stop the simulation and then edit it into, okay, make the LED on for 5 seconds and then off for 1 second. And then again, let's run our simulation. So wait for it to be stable. Okay, it will be on for 5 seconds. You can see 5 seconds, and after 1 second, it will turned off. Okay. Okay, you can already see. And then again, stop simulation. And then again, let's return to the original uh, given for the delay function. And then again, start simulation. Okay, so we have blinking in half a second. So again, it depends upon your internet connection and your computer. So this is blinking for half a second. So for example, so this way you are sure that your code is correct, there are no errors, and at the same time, your components is properly set up because your LED is functioning as expected. So what, for example, you forgot your component is in pin number 11, your LED, then you forgot that you have declared it in pin number 13. And then again, let's simulate it. Actually, this is the problem. This is actually a it's not really a runtime error. So, somewhat a runtime error because the error is not found in the Arduino sketch, but it's actually found in your setup. Okay, so you've declared it as 13, then you're going to ask why it's not working. So you have to check. Since it is pin 11, it should be reflected here as pin 11 also. Okay, so actually that's the problems for electronic component setup and the Arduino sketch. So you have to be very careful. You must remember where did you assign these electronic components, to what pin did you assign them, so that you will have no problem. And as for an experience or as an advice, it's easier to edit the Arduino sketch than to change the connections. So if you don't want to have any problems, you have to, again, you have to remember the assigned pins for your electronic components. So this is actually, since Tinkercad is saving all your projects automatically. So this is automatically saved. So this is already our video tutorial. So I hope that you learned something from this video, blinking LED using Tinkercad. So I hope that um, you will subscribe to my channel and also like the channel. So thank you very much for listening. If you have any questions, feel free to comment below. So again, thank you and good day.